Hello, in this video we're going to learn about signed number representation of binary numbers. We're going to use sign and magnitude, we're going to use ones complement, and we're going to use twos complement. So first, we need to learn about the difference between signed numbers and unsigned numbers. An unsigned number is when we use positive integers only, okay? So for example, 0, 1, 2, 3, 4, and so on. Signed numbers, we can have positive and negative values, okay? So -4, -2, 1, 2, 3, and so on. In the decimal system, we generally use the negative sign or the positive sign, and we put that on the left of the most significant bit. In the binary system, we use the leftmost bit to indicate if it's a positive number or a negative number. In the case of a positive number, we put a 0. In the case of a negative number, we put a 1. In the case of unsigned numbers, we use n bits. 1, 2, 3, 4, 5. We use n bits to represent a number. So for example, 1, 0, 1, 1, 1. In the case of signed numbers, let's say if we have the same number of bits being used, so 5, this first one will be used always for the sign. Again, if it's a 0, that means that it's a positive number. If it's a 1, that means it's a negative number. Signed binary numbers can be represented in 3 ways, using sign and magnitude representation, ones complement, or twos complement representation. In the case of sign and magnitude representation, we use the first bit to indicate if it's a positive number or if it's a negative number. So for example, here we have positive 5. So we have 5 in binary, 1, 0, 1, and then the positive sign we indicated with a 0 in the front. So left to the leftmost bit, okay? In the case of a negative 5, we also have a 1, 0, 1, which is a 5, and then all the way to the left, we indicate with a 1 when it's a negative number. Okay, so for example, what about 7? Okay, so 7 in binary number, we have a 1, 1, 1, and then if it's a positive, we put a 0. In the case of a negative 7, again, we have a 1, 1, 1, and if it's a negative, we put a 1. So it's that simple. What about 13? 13 in binary is 11, 0, 1. If it's a positive, we put a 0 in the front. 11, 0, 1. If it's a negative, we put a 1 in the front. The second method we use to represent negative binary numbers is the ones complement. In the case of ones complement, there's 2 ways of doing it. The first way involves a formula that we have to follow, and which involves subtracting with borrows. The second way of doing this is complementing each bit. So for example, if we want to represent a -3 using ones complement, there's 3 steps that we have to do. First, we have to decide the number of bits. In this case, n is equal to 4. Why n equal to 4? Because a 3, positive 3, it's a 1, 1. That's a 3. So at least we need 3 bits. So in this case, we just chose n equal to 4. So for example, 4 bits, okay? The second step is finding the positive number, which is a 3. In this case, a positive 3, that will be the 0, 0, 1, 1, okay? The last step is just to invert each of the bits, so 1, 1, 0, 0. Okay, so a -3 in ones complement will be 1, 1, 0, 0. What about a -7? Okay, so again, positive 7, we know it is a 1, 1, 1, okay? And we can have another bit to represent the sign, okay? And then we invert all of the bits. So 0, 0, 0, and a 1. So that's a -7 using ones complement. What about 13? Okay, so to decide the number of bits and to find a 13 in binary numbers, we use 1, 1, 0, 1, which is a positive 13 or just a 13. Positive 13 will be adding an extra 0. So in this case, our n was equal to 1. 1, 2, 3, 4, 5, and equal to 5. Now we know 13 is a 1, 1, 0, 1, and the negative 13 in 1's complement will be inverting each of the bits. 0, 1, 0, 0, and a 1. Okay, so this will be our negative 13 using 1's complement. Now 1's complement representation is easy to derive, but it has some disadvantages, especially when using arithmetic operations. It's not really simple to get to the correct answer, and sometimes corrections are needed. So for a more detailed explanation, you can see my other video. In the case of 2's complement, we have three ways of doing this. The first one involves also an equation which requires subtracting with borrows again, which is a little bit tedious sometimes. But the other two ways of doing is not so bad. So we can use 1's complement and add a 1, so plus 1, or we can have a shortcut method. This method requires us to start from the 1's complement representation, and then we add a 1. So for example, the minus 3, it's a 1, 1, 0, 0, and if we just add 1 to that, we end up with a 1, 1, 0, 1. Not that bad, right? What about negative 7? So 1's complement of a negative 7, it's a 1, 0, 0, 0. If we just add a 1, then we have a 1, 0, 0, 1 for the 2's complement. What about 13? 13, we add a 1, so we have a 1, 0, 0, 1, 1. This method, I think, it's very simple. Another way of finding the 2's complement of a binary number is as follows. First, we find the positive binary number, okay? And then starting from right to left, we're gonna copy all the bits that are 0, and then we're also gonna copy the first bit that is a 1. After that, we're gonna complement each of the remaining bits, okay, including the sign bit. So for example, a negative 3, we said that a 0, 0, 1, 1, that's a positive 3. We start with a positive binary number. Starting from right to left, I'm going to copy all the bits that are 0 and the first bit that is a 1. So here the first bit, it's already a 1. So I'm going to copy that one, okay? And then the rest of the bits I'm going to complement. So 0, 1, 1. And that will be our 2's complement binary number. And remember, we're starting from the positive binary number, okay? This is the positive binary number. What about a negative 7? So starting with the positive binary number, 0, 1, 1, 1, and then we're going to copy the first one and then complement the rest, okay? So that's our 2's complement. What about 13? 13 we know is a 1, 1, 0, 1, and don't forget the sign. And then we copy the first one and we complement the rest. 1, 0, 0, and a 1. Okay, so that's a negative 13 using 2's complement. So in summary, we have been converting from decimal to binary, okay? And we have used three representations, the sign and the magnitude, 1's complement, and the 2's complement, okay? So what about going from binary to decimal? So to convert from binary to decimal, we first need to determine if the number is a positive or a negative. So we're gonna look at the leftmost bit. If it's a 0, it's a positive. If it's a 1, it's a negative, okay? So if it's a 0, which is a positive number, we just convert it to decimal straight, and we don't do anything else to it. If it's a negative, we first write the negative sign so we remember that it's a negative number, and then we need to decide if we need to use a sign and magnitude representation, a 1's complement representation, a 2's complement representation. And we're basically gonna do the same process that we did going from decimal to binary, we're going to do the same process now from binary to decimal. So in the case of the ones complement, we invert each of the bits, okay? And then we convert that number to decimal. In the case of the twos complement, we copy all of the zeros and the first one, okay? That's the shortcut method. Then we complement each of the bits, right? That's the shortcut method. Then we convert that binary number that we obtained to a decimal. Okay, so let's do a few examples. So for example, we have these 4 binary numbers, okay? We're gonna do the first one. So we have to first look at the first bit on the left. What is the first bit on the left? That's a 0. So that means that's a positive number. So we have a positive, okay? And then we need to convert the remaining bits into decimal, okay? So in this case, we have a 1, 2, 4, 8, and 16. If we add that, that's 28, 29. So we have a positive 29, okay? So just like that. The next example, for example, we see the leftmost bit is also a 0. So that means that's a positive number, okay? And then we convert that remaining bits into decimal. So 1, 2, 4, 8, 16, 32, and 64. If we add that, we obtain 105. Okay, so we have a positive 105. Okay. What about the next 2 examples? We can see that the leftmost bit is a 1, right? So that means that they are negative numbers. Okay, so just to remember, we can write a negative sign. Okay. Now, depending if we're going to be using a sign and magnitude, a ones complement, or a twos complement, that's the next process that we're going to do. So, for example, we said that's a negative number, that's a negative number, okay? So just to remind us, if we're using the sign and magnitude, we can ignore the first bit, or we just convert it into 0, then 1, 0, 1, 0, 1, 0, 0, and we convert that into decimal. So we have a 1, 2, 4, 8, 16, and a 64. Okay, that is equal to an 84, and our final answer is a negative 84 because that's a negative number. Okay, so what about the ones complement? The ones complement, we're gonna invert each of the bits. Okay, so each of the bits of our original question, okay, not the sign and magnitude. So that's a 1, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0. Okay, let me double check that. So 0, 0, 1, 0, 1, 0, 1, 1. Okay, so now we convert that binary number into decimal, and we obtain a 43. So 1, 2, 4, 8, 32. So that's a 43. Remember, we had a negative number, so that's a negative 43. Okay. In the case of the twos complement, remember we're using the shortcut. Okay, so we copy the zeros starting from the right. We copy the first one that we encounter, and then we invert after that. So 1, 0, 1, 0, and a 0. Okay, and then we also convert to decimal. 1, 2, 4, 8, 16, 32. So you can see that number is what? 32 plus 8, that's 40, and a 44. So we have a 44, and remember we had a negative number, so negative 44. Okay. What about the next example? Okay, the sign and magnitude, we just copy everything and we convert. So we have a 1, which is a negative number, and then a 1, 1, 0, 0, 1, 0, 1. Okay, what is that value in decimal? So 1, 2, 4, 2, 8, 16, 3264. What is that? That's 101. And remember we had a negative number, so negative 101. What about using ones complement? Remember we have to invert all of the bits starting with the original one. Okay, so we're gonna have 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 0. Okay, and what is that in decimal? That's a 1, 2, 4, 8, 16. So that's a 26. And remember we have a negative number. Remember we're starting with a 1. So negative 26. Now the last one, two's complement. We have to use the shortcut method. Remember, starting from the original one. So that's a copy the first one, and then we invert. So 1, 0, 1, 1, 0, 0, and a 0. And then we convert that to decimal. So that's a 1, 2, 4, 8, 16. And so that's it's a 27, but remember, final answer minus 27.